Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening, Duggan, and I'm joined by Sana and Connor.
Hello.
Hi.
Broadcasting live from the Alan Carswell Observatory located at York University in Toronto, Ontario, Canada. Tonight is Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then onto Quirks and Quarks, Western Worlds, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning at 2 a.m. Universal time. The York Universe production works in concert with our online public viewing program run by the Observatory team, which runs between the hours of 9 to 10 p.m. local Toronto time. Go to observatory.info.yorku.ca and follow the links to OPV, online public viewing, and join the chat. Our broadcast is powered by and in partnership with astronomy.fm, the voice of astronomy. For any questions or comments you have of our past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle @York Observatory and on Facebook at Alan Carswell Obs. All of our programs are free, but if you would like to make a donation, please see our website at observatory.info.yorku.ca. All right, everyone, we've got a fun night planned. How are you guys doing?
I'm pretty well. Yeah, how about you guys?
Getting used to the sort of weird weather we've had over the last few days, where it got really warm and then suddenly, there's 1 centimeter of snow on the ground.
Yeah, that was so weird. It was like the warmest day we've had in a while, and then in the same day, just going below zero again. It was so odd.
It's the Canadian almost spring, but technically still winter.
Yeah.
All right, so we're going to kick it off with This Week in Space and Astronomy History. I think, Connor, you're up first.
Yes. So March 9th, 1979 marks the discovery of active volcanoes on Io. So the Pioneer probes were the first human spacecraft to perform a close flyby of Io in 1973 and 1974. However, Io's volcanic nature was not actually revealed until the Voyager spacecraft flew through the Jovian system in 1979. Pioneer 1 did take one image on the moon from almost 800,000 kilometers away, but planned observations made by Pioneer 10 did not actually occur due to software errors that were caused by the intense radiation environment around Jupiter. Following the Voyager flybys, Linda Morbido, a Canadian and engineer for Voyager's optical navigation image processing system, was processing images that had been downlinked for navigational purposes, when she noticed an extremely large plume. When I say extremely large, I mean 270 kilometers high, which is about 15% of Io's radius, emerging from the moon's limb. After discovering this, they looked at other images that Voyager had returned, and they found 9 similar plumes around Io, confirming the existence of active extraterrestrial volcanism for the first time. So, Io's volcanism arises due to this tidal heating effect. Io is Jupiter's innermost moon, so it's very close to the planet. So as it moves along its elliptical orbit, the planet's really strong gravity squishes and stretches Io, which heats it up. Io is now known to have over 400 active volcanoes, which makes it the most volcanically active object in the solar system.
I love how there are so many things that are just discovered by complete accident like this.
It's really sort of it's very fun. I think Linda Morbido, she wasn't even, I guess, someone involved necessarily in the science side of the Voyager missions. And she was just there to process navigational images, which in and of itself is of course something really important. But the fact that you're on that job and suddenly you find this incredible discovery that no one was really expecting.
Yeah, it's always interesting.
Yeah, definitely, and also crazy that volcanoes are something I feel like we associate most predominantly with Earth. You don't really think about other planets having volcanoes when you think of other solar systems. So it's really cool that we do have a moon with such active volcanic activity.
Have either seen the videos of the volcanoes on Io? I think maybe, I don't know which one. I'm guessing probably Juno has taken actual, images, or not just images, but actual movies of these volcanoes erupting. You can actually see the plumes, coming up and spreading out over the moon. It's really sort of impressive how large these plumes are.
For sure. Yeah, I've seen images, but I don't know if I've seen a video. I'll definitely have to check that out.
That'd be really cool to get a video of volcanoes from another planet.
Yeah.
I mean, 270 kilometers, like for reference, the sort of boundary of space here on Earth is only 100 kilometers. So these are really, really huge plumes.
Yeah, and I guess the lack of gravity on Io is mostly to cause for that. Lack of gravity and the really thin atmosphere.
And that is what I would guess.
Yeah.
All right, Sana, I think you have the next one.
Yes. So moving forward in time by quite a few years to March 10th, 2006, which is when the Mars Reconnaissance Orbiter actually arrived at Mars. So this is a NASA-run Mars orbiter mission, which is responsible for taking high-resolution images of the Martian surface primarily. There are also some other instruments on board. And one of the other major things that the Mars Reconnaissance Orbiter has done is to communicate with some of the other Mars rovers as well. So I'll get into a little bit more about some of the things that it has done in a minute. But basically, the Mars Reconnaissance Orbiter was launched on August 12th, 2005 from Cape Canaveral, then arrived at Mars a few months later on March 10th, 2006. And like many of the current and past Mars missions, the goal of this mission was to look for evidence of past life on Mars, in particular looking for evidence of liquid water on Mars, because that's associated with life, and also to investigate the Martian climate and geology. So, like I said before, one of the main things that the Mars Reconnaissance Orbiter did do, in addition to just the science, is to communicate with some of the other Mars rovers. So it was, first of all, able to do a lot of data transmission between the rovers because it had a very high data transmission rate. So it could kind of communicate with the rovers like the Opportunity rover, Spirit, Phoenix, and just kind of relay these communications back to the Earth. It was also responsible for imaging some Mars rovers. It imaged the certain Mars rovers and landers after the mission had ended because something happened to them and they just couldn't work anymore. So this thing could actually take high resolution pictures of the spacecraft on the Martian surface from orbit, which I think is pretty cool. And it was also responsible for finding a suitable landing site for the Curiosity rover, which eventually landed in Gale Crater in 2012. So this was a pretty important mission, not only in terms of just the science that it did itself, but in terms of its role with the other Mars missions that were on Mars in the past. Just a few of its science discoveries, I'll talk a little bit about that. We can't go through all of them because it's a incredibly successful mission, but some of the highlight science discoveries for the Mars Reconnaissance Orbiter were finding evidence of layers of ice near the poles of Mars, which are responsible or kind of indicative of the recent climate variations on Mars. It imaged these two gullies which had formed landslides of this loose, dry material, and also imaged some weird features on the surface that kind of looked like spiders, which were probably come from carbon dioxide gas from beneath the surface, kind of spewing out of the surface and then forming sort of frost-like substance on top of the area that it's spewed out of. So if you want to look up those pictures, those are actually very, very cool. I saw a couple of them. It's a very neat surface feature on Mars. Just like Io, Mars also has, or used to have, some volcanoes. So it also made some observations of those volcanic eruptions and some massive carbon dioxide deposits at the south pole of Mars. It also did quite a bit of work when it came to finding liquid water on Mars, which included finding evidence of these like clay-rich rocks that overlapping bits of that clay-rich rock on a certain part of Mars, and later finding evidence of opal. And both of these require liquid water to form. So there is a lot of evidence for some past liquid water on Mars just because of some of these surface features that the Mars Reconnaissance Orbiter found. And apart from the interesting discoveries about Mars itself, the MRO also did a couple interesting things apart from that. It took some detailed observations of one of Mars's moons, Phobos, when it did a close approach. And it also took some great images of the comet Siding Spring in 2014, which were some of the highest resolution images of a comet that have ever been taken. So the orbiter is still in operation today. It's expected that the spacecraft will continue to operate at least into the later 2020s. And because it'll still be operating then, it will likely be able to assist with a planned sample return mission involving the Perseverance rover. So very, very exciting stuff from the Mars Reconnaissance Orbiter.
Wow, what a mission.
Yeah.
It's really hard to understate how important these orbiters are to the rover missions. I'm on the Curiosity operations team here at York. And basically all of our daily planning is based around, these communication passes from MRO along with Mars Odyssey and Maven. And MRO has also done a lot of the terrain modeling that helps, the rover planners decide, where are we going to drive the rover. These orbital assets are really, really helpful to our landed missions.
Definitely. Even most of, even Cassini-Huygens, that mission, the Huygens little probe that went onto Titan wouldn't have been possible. That mission wouldn't have been possible without Cassini as a relay. So any orbiter is like the instrumental gateway to landing other craft on a planet or object.
Yeah, that's sort of the thing, is the further out in the solar system you get, the stronger of a radio signal you have to send back. You want to communicate directly to Earth. So, it's always a lot easier if you have something in orbit that you can communicate to, which then can, broadcast back to Earth.
Yeah, for sure. And just the overall success of the mission, sometimes you just get those missions where everything just is a cohesive unit and works really well. It's really, really nice to have that. And, to still be in operation much longer than it was originally planned to. That's a great asset for astronomy.
Given how important it is, NASA's gonna, keep that thing running as long as they possibly can. Because, once you lose a third of your orbital communications relay, that's, not ideal. So, I'm sure they are going to run MRO until it literally just breaks.
Yeah.
Yeah, for sure. Run MRO into Mars. And I have no doubt it will have an equally as impressive successor. All right. So for the next event for This Week in History, we're going a little bit back in time again to 1781. And this is when astronomer William Herschel first observed Uranus. So the funny thing about planets is that even though they're so close to Earth, in our solar system at least, and they're some of the nearest astronomical objects to us, they can be the most difficult ones to observe or discover if you don't already know where they are. And this is what happened with poor Uranus, which, like a neglected child, was ignored and passed over dozens of times before Herschel's observation on March 13th, 1781. Prior to this, Uranus had been observed by astronomers Hipparchus, John Flamsteed, who is the first astronomer royal, and Pierre Charles Lemonnier as early as 128 BC. to as recently as 1770, and each of them had written it off as a star or a comet or other astronomical object. And Herschel himself was part of this group, and he initially reported it as a comet to the Astronomer Royal at the time, but other astronomers who continued to observe it around the same time brought doubts forward. So right after he reported this comet to the Astronomer Royal, astronomer Johann Lexell and Johann Albert both began to observe this object as well. And Lexell managed to calculate its orbit. And both he and Albert decided that this orbit is way too circular to be a comet, a distant comet. So it should resemble, mathematically at least, a planet-like body. And soon afterwards, they came to a consensus, and Uranus was declared to be the seventh planet in the solar system, a little bit farther than Saturn. And at that time, that was the furthest planet that was discovered.
I'm always impressed, I guess the work that probably had to be done to, find these things at that time. Like, these days we have these massive surveys that can image the entire sky in one night, and computers that can process all that data. Like in 1781, how do you go about finding a planet when you can only observe a tiny part of the sky at any given time?
Yeah, and their telescopes, not exactly the 1 meter that we have in the observatory right now, because Sana, I remember the first time we were using the 1 meter, it was really the easiest thing we could have used to survey the sky, because it's literally you click on an object and say, hey, I want to see the Orion Nebula, and you click go to, and the telescope just takes you there. Whereas back then they were freehand with a little mechanical refractor telescope. I think that was 8 centimeters in diameter. So yeah, pretty crazy stuff.
We always complain about the 60 centimeter and how much of a pain it can be to use, and it's like this is nothing compared to the telescope that they had so many years ago, and it's really just like remarkable to me how astronomers so many years ago could make like decently precise measurements of things. Obviously not perfect measurements because they just didn't have the technology, but still like relatively precise and very, very good observations of these objects. It's kind of mind-boggling to me that they could do this.
Yeah, even like I think about Tycho Brahe as an example of this all the time, because I can't remember, did he do it with the naked eye or with a small telescope? Oh yeah, he was the last of the major astronomers to work without telescopes. He cataloged a very large part of the sky to an insane degree of accuracy without any telescopes, and his measurements are still considered some of the most accurate early astronomy measurements ever conducted.
I mean, I think some of that still, I guess you could say, haunts us to this day, with the magnitude system. And it's like, oh yeah, this star looks, about this much brighter than some other star, now that we all standardized it, it's all like, oh no, this is a completely insane system that everyone who isn't an astronomer hates because it's bafflingly confusing.
Yeah.
That's the way that was done, so it's the way we continue to do it today.
Yeah, for sure. Yeah. All right, I think Connor, you're up again.
I am indeed, keeping sort of in the past. This is March 10th, 1814, and the discovery of dark features in the sun's spectrum. So this is a story about Joseph von Fraunhofer, who was a German physicist, actually trained in glassmaking. He used that training to manufacture very accurate and high-quality lenses for telescopes. Some of the most accurately ground lenses that you could get at that time. His skill eventually led him to invent the spectrometer, a device that splits a beam of light into a spectrum. Using his spectrometer, he discovered a bright orange line in the spectrum of a fire, a line that did not seem to change over time or between different fires. Of course, he wondered, is this something that occurs in every fire? So he pointed his spectrometer at the sun. Rather than finding a single bright orange line, he found over 500 dark lines in the sun spectrum. This was a bit curious, so he then pointed his spectrometer at other stars, at which point he discovered that their spectra also had those dark lines, but not the same lines as the sun. This meant that the lines were not the result of interactions between the light in the Earth's atmosphere. If they were, then you would expect that the lines would be the same no matter what star you point at. So Fraunhofer concluded that the lines must tell us something about the stars themselves. In the process, accidentally inventing stellar spectroscopy, which is arguably one of, if not the most important developments in modern astronomy. However, what exactly these lines told us would not actually be determined until 1859, when Gustav Kirchhoff and Robert Bunsen found that these lines represent different elements in the stars. They actually named them Fraunhofer lines in Fraunhofer's honor. And some of his original alphabetical designations are still to this day used to reference the lines, even though we actually know what elements correspond to each line. For example, the calcium-2 doublet around 395 nanometers are still called the H and K lines.
Yeah, another one of these accidental discoveries that became one of the really important and instrumental discoveries for astronomy. Spectroscopy is super common now. We use it all the time. And Sana, is the spectrograph installed on the 1 meter now?
It's coming. Dr. Hyde started setting it up, so we should be getting the spectrograph going soon.
Almost there. We're gonna honor Fraunhofer with his discovery with our spectrograph, because it's crazy how they used to discover things back then.
It's like, again, imagine you're just some German guy who's good at making glass, and you accidentally discover the fundamental thing that helps us understand the nature of the universe.
Yeah.
Yeah, that's spectroscopy is spectrometry is spectroscopy. Okay, I was wondering if it's the same chemistry astronomy. Is basically the first thing you look at when you're looking at a new star or anything like that. That's the first go-to when you're like, okay, what's its composition? And then everything else is based on that.
Yeah, that's always the thing is that's even observing galaxies, it's all we can get a bunch of photometry and direct images on things, but everyone just wants to go get the spectra once we know what to look at.
Yeah.
So it's one of those things where I understand the science behind it, but it's still incredible to me that we can just gather a bunch of photons and from that we know what elements are in it, how far away these objects are, how fast they're moving, all these things, all just a bunch of photons that we've picked up.
Yeah.
Even with exoplanet transits, you can tell the composition of an exoplanet through a spectrograph of a star with and without the planet transiting in front of it.
That idea is still so crazy to me that you can just take a spectrum of an exoplanet. And I mean, the whole science behind it makes sense, but I don't know, just that idea that you can take a spectrum of a planet is just crazy.
Yeah, definitely. I think we're sticking to the topic of Uranus in our solar system with this one. Sana, take it away.
Yeah, topic of Uranus and accidental discoveries, because this was another one. So on March 10th, 1977, 3 astronomers, James Elliott, Ted Dunham, and Jessica Mink, discovered that Uranus has rings. The presence of rings was originally suspected by William Herschel, who, as we just learned, discovered Uranus a few years ago. not a few years ago, many, many years prior to the discovery of the rings of Uranus. But they were only actually confirmed to exist years later with this observation. So like I said before, the rings on Uranus were discovered completely by accident. What the astronomers were trying to do in this case was to take advantage of an occultation to study Uranus's atmosphere. So Uranus was going to be passing in front of this star, which the catalog number is SAO 158687. And as it passes in front of the star, it kind of blocks some of the light of that star, and you can use that dimming to study the atmosphere of Uranus. So they were using, to make these observations, the Kuiper Airborne Observatory, which is, if any of you have heard of NASA's SOFIA Observatory, is, I think, the predecessor to that observatory. It's a highly modified Lockheed C-141A starlifter that's modified to have a 91.5 centimeter infrared telescope on board. So they can fly this plane up to very high altitudes and get above a lot of the atmosphere, and then the telescope can take images while not having to worry too much about the Earth's atmosphere, which absorbs a lot of infrared wavelengths. And to the great surprise of the astronomers who were observing Uranus, they found that the star disappeared more than once, a few times just before and a few times just after Uranus passed in front of it. And they concluded that that must indicate a ring system at Uranus, because there's nothing else to really block the light from the star. So they concluded Uranus must have a system that included at least 5 rings for what they observed to be possible. So it turns out that these were the second set of ring systems to be discovered in our solar system. The only ones that had been discovered at that point were the rings of Saturn, which are fairly obvious when you look at the planet. And this set of ring systems was later confirmed during Voyager 2's flyby of Saturn in 1986, which also discovered 2 additional rings at Uranus. Imaging from the Hubble Space Telescope a few years later also revealed that Uranus had more rings, bringing the total up to now 13 rings. So follow-up observations of its ring system, which includes observations from Hubble, reveal that the ring systems can be split up into 2 sets, an inner set of narrow and dark rings, and an outer set that are brighter and have red and blue colors. The ring system is likely young, no more than about 600 million years old, and they could be the remnants of some of Uranus's moons that collided and broke up in orbit around Uranus. So I think it was the tidal forces kind of tore them apart after the collision, and then they ended up making this ring. Or they could have been these Pluto-like dwarf planets that came a little bit too close to Uranus and got torn up by the gravitational force and made the rings.
Okay, so how willing are you to believe that William Herschel actually saw the rings in 1781? Like, I'm willing to give him the benefit of the doubt and say that, he has the telescope ability to actually see the planet, but to see its rings in 1781, I find that highly suspect.
Yeah, they said that he suspected that they were there. The link that I saw only said that, so I highly doubt that he actually, imaged the rings, or he couldn't image them, but just found direct evidence for them. But it might have just been a note oh, maybe this planet has rings or something in it. But yeah,
it's like there's a little smudge on his telescope, and it's oh, maybe this is rings, and he was accidentally right.
I mean, a lot of the original observations at that time described it as a nebulous object because, again, it's so far away. It's so dim. It's not even one of the planets that you can see with the naked eye here. So, Saturn and Jupiter we see all the time. And then you have any telescope, basically, even a pair of binoculars, and you can probably see the rings on Saturn. But he thought it was a comet. So I'm not sure. I'm sure if he thought it was a planet, and then he was like, okay, if Saturn has rings, then Uranus might have rings too. But I do doubt that he saw them.
Oh yeah, I don't think he did.
Yeah.
It took Hubble Space Telescope imaging to find the rings, and I'm willing to bet that those Hubble Space Telescope images had fairly long integration times. to be able to pick those out. So.
Oh yeah, and the rings are skinny. They're like tiny, tiny rings.
Mhm. Yeah,
They're not.
I've seen the pictures before, and they're dark too. So.
Yeah, nearly impossible
Yeah,
without good telescope power.
I wonder if anyone's looked into like what way Uranus was facing compared to Earth at the time that we found that Herschel found it. Like if the rings were like edge on to Earth, then there was no way that he would be able to see them. But if it was face on, still probably no, but at least plausible.
Mhm.
Maybe, for sure. All right, so everyone, to all of you just joining us, you're listening to York Universe, the astronomy and astrophysics program, written and presented by the students, faculty, alumni, and friends of York University. Tonight we have a great presentation we just finished This Week in History, and we'll be on to our news items soon. York University also conducts a Teletube program on Wednesday nights. This week, you can join them for a virtual tour of the Allen I. Carswell Observatory's 1-meter telescope, led by Professors Elena Hyde and Professor Paul Delaney. Tune in at 7:30 p.m. local Toronto time on Wednesday, March 9th on YouTube at York U Observatory to find them. And this week in the sky, we also have a few interesting planets that are up. So on March 12th, Saturday morning, you'll be able to see a Venus and Mars conjunction. And in the southeastern sky, just before sunrise, in the constellation Capricornus. The two will be about 4 degrees apart, with Mars south of Venus. If you use a telescope or binoculars, be careful about the sun. We don't want you damaging your eyes, but it should be a pretty great sight. So happy observing if you have clear skies. All right, let's get on to our news stories. Connor, I think you're first.
Yeah, so keeping with, I guess, what ended up being tonight's theme of the outer planets, NASA has begun assembly of Europa Clipper. So currently scheduled to launch in October of 2024, Europa Clipper will be the first spacecraft dedicated to studying the watery Jovian moon. Last week, the first of these spacecraft's 9 science instruments, an ultraviolet spectrograph, was delivered to JPL from the Southwest Research Institute in San Antonio, Texas. The remaining 8 instruments are scheduled to arrive over the next few months, with the expectation that all of the flight hardware will be assembled and ready for testing by the end of this year. Clipper's primary science goals are to confirm the existence of a liquid water ocean beneath Europa's icy shell and to study the chemical composition of that ocean. Interestingly, despite it being a Europa-specific mission, the Clipper will not actually orbit Europa. Instead, it will be inserted into an orbit around Jupiter that will allow it to conduct 44 close flybys above Europa's surface at altitudes between 25 and 2,700 kilometers. This was done out of concerns for the detrimental long-term effects that the intense radiation environment around Jupiter could have on the spacecraft. You might remember from earlier in the show, I mentioned how one of the Pioneer missions, their planned imaging of Io actually fell through because of the same intense radiation environment. So the Clipper will complement ESA's Jupiter Icy Moons Explorer, or JUICE, which will be studying Ganymede, Europa, and Callisto during the same time that the Clipper is at Europa. And actually, as a little fun fact, although the Clipper is being launched a year and a half after JUICE, it will actually arrive at Jupiter about a year and a half sooner. This is because the Clipper is being launched onto a fairly efficient transfer orbit by Falcon Heavy that will only require 2 gravity assists, one by Mars in February of 2025, and then one of Earth in 2026, while JUICE will actually require 6 gravity assists, one of the Moon, 4 of Earth, and 1 of Venus.
That'll definitely be an exciting mission. I don't think Europa is definitely one of the more interesting moons we have in our solar system, but not one that has been had as much of an opportunity to be explored.
I mean, it's kind of difficult to get out there. I mean, for launching Europa Clipper in 2024, it's not supposed to get there until 2030. So it's you know it's a dedication of some time if you want to study the outer solar system.
Definitely.
I'm
It's
really
like, sorry, go ahead.
yeah, I'm really looking forward to these because there hasn't been a ton of like missions dedicated to moons of gas giants. So it's like they have been studied by some of the other orbiters that are just mainly focusing on the main planet itself. But I'm really excited about this just because if you think about how much you learn when you send a mission specifically to study one object, you learn so much about it. So this is very exciting.
Yeah,
Yeah,
has there been a time when we've had multiple spacecraft at a planet in the outer solar system before?
I don't
I
think
feel
so.
like Jupiter has had multiple, I want to say.
Jupiter had more than one, but I don't think at the same time.
Oh, that's true.
Yeah,
Yeah,
I'm
I don't think it's I don't think it's happened before.
Crazy. Even just getting
It's
out
also
there in recent years, we've only really had Cassini and New Horizons.
mhm.
I mean, it's a very exciting time because in addition to these two missions, there's also the Dragonfly helicopter that's being sent to Titan at around the same time. It's currently scheduled to launch in 2027.
Oh, yeah.
Yeah, I forgot about
Completely forgot about that one.
that. Is so cool.
Yeah, I guess that Ingenuity helicopter kind of is setting more things in motion like that.
We're getting space helicopters. I'm
It's going to
excited.
be
I
a
think
fun time.
For why, but
I
space
think
helicopters are cool.
I think Ingenuity and Dragonfly sort of are on opposite ends of the helicopter spectrum because Ingenuity has this really difficult system where it's a fairly massive planet that it's on with a really thin atmosphere, so it has to have these huge blades that spin really, really fast. Whereas Dragonflies are a relatively small object with a really thick atmosphere, so flying on Titan is actually quite easy.
Yeah, for sure. That definitely, yeah, it's a huge difference. And I wonder how they'll adjust to that once they're there because they haven't really flown helicopters anywhere with a super thick atmosphere, but I guess that's what water tests are for.
Mm-hmm. Yeah, I remember reading somewhere that if you were standing on Titan and you strapped big wings to your arms, the atmosphere is actually dense enough that you could fly just by flapping your arms with
Yeah,
those wings attached, of course.
yeah, I heard about that too.
Would you guys support me if I went there and changed my name to Icarus?
Well, I guess the good thing is that you're further away from the sun, so your wax will be at less of a risk of melting.
Exactly. I'm taking the necessary precautions. Sana, I was going to mention earlier during your This Week in History segment that your probably two main loves are telescopes and airplanes, and the telescope on the airplane is like the peak achievement
Oh yeah.
for you.
Yeah. Yeah, it's
And now we've got helicopters in space. That's like aviation and astronomy intersect, and here we are.
yeah, you just need to put a telescope on one of the helicopters now. I'm not too sure how useful that would be, but it would be cool.
I'm writing an email to NASA right now. We're gonna make it happen. All right.
Aircraft
So
mounted telescopes are really something.
yeah,
Yeah.
Like imagine, like like flying a plane, how much turbulence there can be. Like
Mhm.
imagine trying to point a telescope out the window
I,
with all
I
of that.
I saw this like special, I don't remember what show it was, on the Sophia aircraft, and they did, I'm not too sure how they did it, but they basically showed like this time lapse of how the plane stabilizes itself to keep the telescope pointed where it should. And there's just it has to like near constantly doing these incredibly tiny corrections just to keep the telescope stabilized. So it was this really cool video of the telescope just not moving at all, completely stable, and the plane just like bouncing around. It was a really interesting thing.
Yeah, for sure. All right, so for our next news story, um, we're gonna kind of stay a little bit closer. We're gonna stay on Earth, um, but we're gonna learn a little bit. So we've long known that the ice locked up in glaciers around the world is full of secrets. I'm sure we've all heard stories about the crazy pathogens or bacteria or extinct animals, maybe even humans from thousands of years ago, brought back to life after being frozen in ice blocks for years. Like the movie Captain America happened. This is something we've toyed with as an idea for a while. But astronomers might also have a vested interest in the glaciers too. It turns out glaciers and other long-standing ice shelves can store evidence of solar flares. A solar flare is basically a type of solar storm, and it is a jet of electromagnetic radiation that gets ejected from the sun. And sometimes not, but sometimes, Earth is in the path of such a flare, and the radiation, usually in the form of high energy gamma rays, causes phenomena like aurorae, northern lights, when interacting with Earth's magnetic field. This battery of gamma rays from the sun can also cause the formation of radionuclides or radioisotopes, which are high-energy atoms that emit radiation as they decay. These radioisotopes usually have a known half-life, and therefore they can be used to determine ages of archaeological samples or other historical objects. So one example of this is carbon dating, which uses the radioisotope 14 carbon to determine the ages of historical objects. So anytime we unearth a mummy or something similar to that, the way we would tell if that object is a certain age is by looking at the amount of carbon 14 relative to other carbon in that sample. So a recent study conducted by researchers at Lund University in Sweden examined ice cores from glaciers in Greenland and Antarctica, and they measured the amounts of beryllium and chlorine radionuclides, sorry, not nucleotides. My biology is coming through. Radionuclides in different layers of the ice cores, and they actually found evidence of a massive solar storm that occurred over 9,000 years ago. So when they went layer by layer, especially for recent years, they were able to find concrete evidence of these isotopes in layers where we had already known that there was a solar flare. So 70 years ago, 700 years ago, they knew that there were solar storms that happened around those times, and they could match up those layers to those solar storms. And all of them have a relatively similar intensity level, but they actually found a storm over 9,000 years ago that occurred. And based on the amount of radioisotopes in the ice, the storm looks to have been severe. And by severe, I mean it would have been a disaster if a storm of that caliber were to hit Earth today, because the radiation can interrupt aircraft telemetry, satellite telemetry. It can cause widespread blackouts. Actually, the entire province of Quebec was blacked out in 1989 by a solar storm. And so, yeah, you can imagine the chaos that would be caused around the world if a solar storm were to hit us, because they usually don't target specific areas either. It's Earth as a whole. So this solar storm was a pretty bad one. And it actually occurred during the solar minimum, where solar storms are not as common. So it was a pretty unlikely event. And we haven't had one of that severity since. So, new fear unlocked, new solar storm fear. That's what we're unearthing from the ice cores.
Yeah, it definitely reminds you of the danger of living near a star. Like, it gives us life. It is necessary for us to be here. But also, there's a possibility that, it might be in a bad mood one day and decide to end modern civilization just because it wants to. And there's nothing that we can really do about it.
It doesn't know a thing. It doesn't know what it's doing. And yet it could wipe out billions of years of life in the making.
I think this particular discovery also, I guess, shows off sort of a consequence of climate change that maybe we don't really think about. Like once ice caps melt, you're not going to be able to get this, historical record back. Even if, we were to stop, climate change, right here, right now, at this very second, like any of that historical data that was locked away in the ice that was gone away, like there's no way to bring that back.
Yeah, that's a good point. Once the ice caps here on in the Arctic and the Antarctic melt, and in Greenland as well, that's a lot of information lost. And like I mentioned earlier, who knows what's in there, because it's really hard to core ice samples and we don't know what's in there yet.
Yeah, I mean, I think one of the big fears is, with all the permafrost in like Siberia and all the methane that's been locked away under there, as it melts, it releases that methane into the atmosphere, and it is a potent greenhouse gas. So, all these things are just locked away in the ice, just waiting for it to be melted away, to be release itself into the atmosphere.
Yeah, it's definitely a positive feedback loop. Once it starts, they're not, the albedo of the Earth goes down, thereby increasing or decreasing reflection of light back into space instead of trapping it in our atmosphere. And then you get the greenhouse gases being let loose. And I'm pretty sure it's also, in addition to methane, a carbon dioxide store in the ice caps. So there's a lot that's slowly going wrong, and we're not going to know the full extent of it for a while.
This turned into a bit of a depressing topic, I would say.
Yeah. How about we change the topic to the moon, Senna? You've got a couple interesting things to cover here.
Yeah. So maybe some of you have heard about this whole thing with a piece of rocket debris hitting the moon. So this is a pretty interesting news item, I think, because for the first time, somebody has been able to predict a man-made object slamming into the surface of the moon. So this happened, or was predicted to have happened, on March 4th at 7:25 a.m., according to some calculations. This piece of debris likely impacted the moon near the Hertzsprung crater, which is about 570 kilometers wide. And based off of some estimates about the object, it's probably around 4 tons. And at the speed it was moving, it probably would have made a hole on the surface of the moon about 10 to 20 meters across. So this impact happened on lunar far side, so no ground-based telescope would have been able to see this. So far, there's some orbiters around the moon, like the Lunar Reconnaissance Orbiter. So far, none of them have actually been able to have actually observed either the initial impact or the crater that it left behind, but they might. So I'm pretty sure there are some people who will go looking through all of this data from the orbiters on lunar far side to try and find some evidence of an impact of the moon. So I guess keep an eye out for that, because they might find evidence of the crash. But overall, this is one of about 58 or so missions internationally that have left some kind of debris on the moon, starting with the very first one in 1959, the Luna 2 mission, which was an intended impact onto the moon. A ton of other spacecraft have left debris on the moon, some of them part of the Luna program, some of them part of the Pioneer and Ranger programs, and even some other decommissioned satellites, as well as debris left over, of course, from the Apollo missions. Not only did the Apollo astronauts leave a bunch of stuff behind on the moon, including part of the lunar modules, but NASA also intentionally crashed the third stages of the Saturn V into the moon during those sets of missions. However, like I said before, this situation is kind of unique because this is the first time ever that a man-made object was observed colliding with the moon, or a man-made object has been predicted to collide with the moon unintentionally. There is a little bit of uncertainty about where this piece of debris came from, though. Astronomers are pretty sure that it is a man-made object, so it's not just like some space rock or something impacting the moon. It is a man-made object. It was initially thought to be a SpaceX second stage from the Discover mission that launched in 2015, and with the Discover standing for Deep Space Climate Observatory. However, after some more investigating, it's now most likely to be a Chinese booster from the Chang'e 5-T1 mission, which launched in 2014. This was a technology demonstration mission for the later sample return mission called Chang'e 5, which launched in December 2020 and then returned samples, I think, late last year, if I'm remembering correctly. China has disputed this claim that it is their second stage, though, citing that it's hard to tell what the origin of that object is. There was also some Space Force data that initially indicated that the object that second stage of the booster had collided with the Earth, or not collided, but it re-entered the Earth's atmosphere and presumably burned up. But it turns out that after some more looking into that Space Force data never actually said that it did re-enter the atmosphere. That was just based off of some extrapolation. So there is a good chance that this object did come from the Chinese Chang'e 5-T1 mission. However, they do dispute it, so don't exactly know for sure what the identity is. But pretty interesting, and hopefully we'll find some evidence of this impact on the moon.
Yeah,
maybe I can give William Herschel a little bit of leniency here. If even with all of our modern technology and super advanced telescopes, and we still don't know what exactly it is that we just launched into the moon on accident.
Yeah.
And the trouble is, there's just so much space debris out there nowadays.
Oh yeah. Yeah, and this kind of highlights another kind of problem with space junk at this point, is that there's so much pollution of space junk in Earth orbit or in lunar orbit. I mean, there's been quite a bit of controversy about the SpaceX Starlink satellites because they're messing up astronomy images, but then those are controlled satellites that are currently being used, but then you also have a ton of other space debris, hundreds of thousands of tiny pieces, many of which don't even show up on any radar or on any imaging, that are just kind of floating around up there. And at the speed things are going in Earth orbit, if there's a collision between them and some important spacecraft, or with spacecrafts like the International Space Station, that's a huge problem.
Yeah, at that point you're risking the safety of the astronauts on board. You're risking safety of people on Earth because, if there's a crash between an unmanned and relatively unmonitored satellite and some space debris, who knows if that's going to go out into space or come back and land on Earth. I mean, we would hope it would splash down somewhere that's not, habited, but we don't have that guarantee.
And there has been some other issues with that too. I think maybe a couple of years ago, I believe it was with the Chinese booster that it just kind of burned up in the Earth's atmosphere, but there was a chance that it wouldn't have burned up fully and could have landed on some populated area. Or years ago, I think it was with Skylab, of when that thing deorbited, it just kind of like, I think pieces of it fell over Australia. So
Yeah.
It's kind of a big problem of like, what do we do with these satellites when they're done? When we're done.
And then even I think the Chinese booster that was that projected to land near Italy. I think Gianluigi was in Italy at the time, and he wanted to go out and see if he could get a piece of it. I don't think he was able to, though. But I mean, I would do the same thing if rocket debris was landing in my backyard or any close vicinity.
Yeah. It's kind of a problem at this point. And I think I've also heard of some interesting like missions that people are trying to put together to clear some of this space debris. But it's a huge thing to do. So yeah.
Well, it's kind of like think about even ocean cleanup. Like the Great Pacific Garbage Patch is next to impossible to clean up, and that's on Earth.
Yeah.
And then, to go out into space and to try and collect debris that we can say there's a lot of debris in the atmosphere or in Earth orbit, but realistically it's not close together in like reachable distance.
Yeah, and then
you know what I mean?
Yeah, and then there's also the fact that there are useful satellites that are still in operation that are like kicking around in near space junk. So if you're going to go and try and clear space junk, you have to be careful about what you're doing.
Yeah, the only real solution I think we could have is to have a better way, a planned way to retire all these spacecraft that we're putting up.
And also future planning. So just, I'm not sure entirely what the process is if you want to launch something, but there should be some more like kind of accountability on behalf of people who launch the satellites. Like, don't launch stuff you don't need.
Yeah, for sure.
Yeah, like just be very careful about what you're launching, and like you said, what you're going to do with it when it's done its lifetime.
I do like that they're leaning more towards reusable rockets nowadays, because there's minimal debris that comes off of them. Like the Falcon Heavies go up and come down in one piece.
Yeah.
So I hope we lean more towards that instead of rockets with, the engines that just come apart after they've done the initial burn, because I understand why they do it, because they don't need that weight anymore, and it would just hinder them in the rest of their space flight. But where does that go,
It's also so much more cost effective of reusing parts of the spacecraft apart, instead of having to just make a new one every time.
Oh yeah, it would definitely be more cost effective, especially for a longer mission like they're planning Artemis, or they're planning a future Mars mission. It would be a lot easier to be able to use one rocket and modify it, use the parts, and send it back and forth. It can land wherever it wants to, rather than, as soon as you launch it once, it's gone. All right. So, well, everyone, you have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been myself, Buggan, and Sana and Connor. Stay tuned, because it is Science Night in Canada. Coming up next is Quirks and Quarks, Western Worlds, and Science for the People. You can always connect with us on Twitter with the handle @YorkUniverse, and check out our website for show notes, content, updates, and contact info at observatory.info.yorku.ca. Thanks for tuning in to York Universe, clear skies, and have a good night. Thanks for joining us.
Good night.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of astronomy.fm. This program has been released under Creative